Frequency Podcast Network. Stories that matter, podcasts that resonate.
David Bowie once sang, "Is there life on Mars?" Well, we may have an answer thanks to incredible work done by NASA and hundreds of researchers around the world, including a few here in Canada. NASA's Mars rover has discovered the clearest sign yet of possible past microbial life on the so-called red planet. It comes in the form of a rock sample collected by the rover about a year ago that caught the eye of experts and researchers, which then led them to examine it further. It's potentially a major find. Possible past life on another planet. I'm Cormac Mac Sweeney, and today on The Big Story, I'm speaking with Dr. Mariek Schmidt, a professor of earth sciences at Brock University who studies rocks on both Earth and Mars, and was one of the researchers helping NASA with this discovery. Thanks very much for joining us.
Thank you for having me.
So how does it feel to be a part of a research team, international research team that worked on this project?
I'm just very grateful to be a part of it. It's been a big part of my career, and I really enjoy the people and the rocks, and it's just exciting to be able to work with these people and explore Mars.
And exciting for a big discovery like this, right?
Absolutely. Absolutely.
So let's start from the start then, because this wasn't a discovery that just happened this week. It took a lot of time. There was analysis. Experts had to come to some sort of conclusion on what they were looking at. So how did this all begin? Tell me about the process and when you first got involved.
Well, I mean, I've been involved with the Mars 2020 mission since landing, essentially, as a participating scientist. And I've been really involved with the Pixel instrument, which is a microscopic X-ray spectrometer. And basically what it does is it measures the chemistry of very fine scale chemistry of rock surfaces. So I've been involved since landing, and the rover landed on the floor of Jezero Crater back in 2021. And since 2021, the rover's been basically on its way out of the crater. And so on its way out, there is a canyon system called Neretva Vallis, where the rover basically climbed up into that canyon system that empties out into the crater. And so we knew that this was a target that we were going to be really interested in because there would have been flowing water in this region. When we came upon this rock, it was very fine grained, and then which is a very good indication that there could potentially be organics preserved in this rock. And then but also on the surface of this rock were very interesting textural features that were intriguing, that we'd never seen before. And so for this particular rock, we came upon it and analyzed it actually when the entire team was together in Pasadena, California. We do this annually. We come together, and it just so happened that this rock was analyzed at that team meeting. And during that team meeting, I actually stood up and gave like a pop-up presentation about this rock. So I was the first person to present about this finding from the Pixel's interpretation of this rock. And so it was very exciting to be part of that. And once we realized that these unique textural features are associated with organics from a different instrument, from the Sherlock instrument, that was when we were like, oh my gosh, there's something going on there.
You're not the only Canadian who worked on this. Who else was helping in the research?
Yeah, so I'm involved on the Pixel instruments. I had a postdoc who was very involved with this, who's also a co-author on this paper, Tanya Kazovsky. She's now an assistant professor at Brock University. And we also there's some Canadians who are based at the University of Alberta, Chris Hurd, who's a professor there. And also Ed Clutis at the University of Winnipeg.
It's wonderful that we had a few Canadians out of hundreds of researchers around the world. So tell me a little bit more about the rock. There was, a leopard print kind of design that you noticed, and what was it about that tipped you off that there might be some organic life there?
Yeah, so it's a potential biosignature. So what it is are there these, and a leopard spot is a good way to describe it because there's this the rock itself is sort of orangey tan. And then there are these spots that are on the order of about a micron across. I mean, not a micron, a millimeter across. And they have within them, it's like a bleached spot in the middle. And then there's a dark ring around it. And with the pixel instrument, what we're able to see is that those darker regions are enriched in iron, and they're also enriched in phosphorus. And so they're iron phosphate minerals. Phosphorus is a mineral that is required for life as we know it. And iron in this instance would have been reduced iron. And then we found that those two things were occurred in addition in the same places where organics were found. And so those three things suggest that there could have been that these could be a biosignature.
Okay, so how did you rule out, the possibility of some other sort of chemical reaction or thing that had happened that could have left these marks as well? How is it so significant compared to that?
I would say actually that it's more that we can't rule out life. Do you see what I'm saying? It's a different way to think about it. So there are chemical processes that could potentially form these same features. But we can't rule out the potential that life was involved.
When you started to realize that, this could be a sign of organic life, I mean, what was that feeling like as somebody who's devoted their life to science and this sort of study?
Oh, it's super exciting. It's just like felt like it was a momentous occurrence, and we're like, this is what. Honestly, we all felt like this is what's going to be able to be used to justify sample return, as we really want to bring these samples home. And so that's because, the goal of the mission is to collect a suite of samples. Hopefully they will contain evidence of biosignatures. And this was the first one that is like a big, visible potential biosignature. Because up till now, we found like hints of organics in some places. We've seen evidence of alteration formed by water. So there would have been water interacting with all these rocks. We've seen carbonates, carbonate minerals, which also indicate that there are fluids interacting with rocks, but they're not biosignatures. Now we're at a point where we can say maybe this is a potential biosignature.
So tell me about the timeline of when you think these possible organisms lived.
That's a good question. If it would have been in like probably about 3 billion years ago or more, so a long time ago. And so, but at the same time, these are some of the youngest rocks that we've examined in the Jezero region. So some of the Jezero Crater region, the rocks around Jezero Crater are really, really old.
Okay, so how does that line up with our planet and when life was starting here on Earth? Before that, roughly the same time, later, and then why did we see an evolution where we are today that Mars didn't see the same sort of changes?
Okay, so life on Earth is thought to have potentially gotten started about 3.8 billion years ago, something like that. Basically, pretty early on in our planet's history. And yeah, you're right that Mars and Earth are thought to have gone through similar kinds of evolutions early on in our planet's history. But what the big difference is that Mars is just farther away. It's a colder planet. So it's also a smaller planet. So it cooled down more rapidly, and it doesn't contain plate tectonics and an active dynamo, which would fuel the magnetic field. And so on Earth, our planet is much more protected. We have ongoing plate tectonics, which means that the outer surface of the outer crust is periodically, set back down into the planet's interior. And so there's a recycling that's going on in our planet that's distinctive. Whereas on Mars, the surface of Mars is much, much older. And it would potentially preserve those first bits of life if they ever started to form there.
Okay, and you're hoping that through more exploration, we might find other signs of possible life. Is it possible that it went beyond just, microorganisms?
I highly doubt that.
Okay. As someone who grew up loving the X-Files, I had to ask that. All right, we'll have more on the big story with Dr. Schmidt in just a moment. So you did mention that the next step is trying to bring this sample back to Earth. How long of a process could that take? What are the opportunities for NASA to do that? And what are the roadblocks that could stand in the way to that?
Right now, the Mars sample return mission is it's unknown whether or not it will ever happen. But the concept of Mars 2020, the rover Perseverance, was always to collect these samples and return them to Earth. And we knew that was going to be an expensive endeavor. There have been many ways that people have thought about how to drive the science forward. How are we ever going to find out whether or not life is on Mars or elsewhere? And the only way to do it definitively would be to actually collect samples and bring them back and look at them in labs on Earth. So that was always the goal for a long, long time. However, it's expensive, right? And it takes a lot of time to plan it. The Mars sample return mission would include sending, so first collecting the samples, which is phase 1. Next would be a lander mission with an ascent vehicle where the rover would deliver the samples to that ascent vehicle and then launch it into space, into orbit. And then there would be a third spacecraft that would retrieve those samples, basically retrieving something the size of a basketball from the orbit of another planet and bringing it back to Earth. So that is another step. And then finally bringing back to Earth and crash landing on Earth. So there's going to be multiple stages to this, and it's very expensive. The best estimate is that it would be something like $11 billion to do this. So it's incredible. It's super important to drive the science forward. However, with the Trump administration coming in, and they as soon as Trump administration came in, they started to cancel missions left and right. They are right now the Mars sample return is not funded any longer. So Perseverance is still collecting samples. We are still trying to justify their return. And I think these samples go a long way in justifying their return. What the Trump administration would like to do is to instead send humans to collect the samples. However, that's not feasible for many, many reasons. One being that humans have to, if they're going to Mars, they have to create their own rocket fuel to return back. And how they would do that would be to use water that is found in the subsurface. And there's no water found in the Jezero crater region. They're basically restricted to sending humans to the poles. So it's not feasible to send humans to get these samples. It has to be a robotic mission.
Okay, so it'd be much more dangerous and possibly more expensive to send humans to Mars instead of a robot or another spacecraft.
Yeah, that's a whole other thing. It would cost more.
Yeah.
But some people really want to send humans to Mars, so they're willing to make that.
Is there a way that other space agencies, including the Canadian Space Agency, could help out? If we're seeing, a lack of funding or initiative from the U.S., could there be opportunities here for others like Canada to step up and help out to make this happen? Or is NASA so big that you need NASA's involvement to make this work?
I think we definitely need NASA's involvement, but I think that the Canadian Space Agency and European Space Agency, UK Space Agency, there's so many around the globe now that are really interested in understanding Mars and potential for life. That yes, there is definitely potential for Canada and other countries to step in and play a larger role. I think there is one danger, however, that if these samples are left too long, that other space agencies may take the initiative and come collect them themselves.
And that could be problematic for the research you've already made so much headway on.
Yes.
If you did get the sample back, what are you hoping to learn through sampling the rock? And what are the knowledge opportunities that expand from this potential discovery?
Well, I think once we get the samples back, we will be able to go to much finer detail. So right now, the finest resolution that we have is on the order of 150 micron size. We'll be able to go much, much smaller than that. And, microbes are on the order of a micron. So we're going to be looking at much more finer detail, looking at what is the chemistry of their organics, what are their textural relationships with the minerals that are present, and to be able to really, hopefully, definitively say that these are a biosignature. Right now, we're just saying it's a potential biosignature. Once we get to that step, we can hopefully say that it is a true biosignature.
And is it necessary that you have the sample to make that confirmation?
Yes. Yeah. In our Earth-based labs, because the instrumentation to do those kinds of analyses are huge. Like they take up wings of science departments and universities and other research institutions. So it's not like we can send those kinds of instruments to Mars readily.
Is there more that we could learn about, our own existence through studying life on another planet? Are there any other practical applications we can have from discovering more about the possibility of life on Mars?
Yeah, I think we would learn about the origins of life on our planet if we can understand the origins of life on other planets. So that's where that really comes down to it. Because, all life on Earth has basically has superseded that initial brain that kicked off life on our planet. And so if we can go to a planet surface that is much older, hopefully we can understand that sort of primordial life and what really kicked it off.
This isn't just amazing for scientists who are currently in the field. Do you hope that discoveries like this will really inspire a lot of younger people to maybe get more involved with the sciences?
Oh, absolutely. Yeah, absolutely. We study other planets because it's inspiring. And this morning I taught a course on planetary science to Earth science majors, and they were just super excited that I was involved with this.
Dr. Schmidt, thank you so much. Really appreciate your time today and to explain this all for our listeners.
Thank you for having me.
That was Dr. Mariek Schmidt, a professor of earth sciences at Brock University and a geologist who studies rocks on both Earth and Mars. She was also a part of the effort with NASA and hundreds of other researchers from around the world that led to this possible discovery of signs of organic life on Mars. I'm Cormac Mac Sweeney, and that was The Big Story. You can send us your feedback on this episode or any other episode by emailing us at hello@thebigstorypodcast.ca or leave a voicemail at 416-935-5935. You can find us on the Seeker app or on all your favorite podcast players. Please rate, review, follow, and share. Thanks for listening.